already did up till question number 5. Okay, tell me, Hamna, one thing, like which chapter is going on in your school right now? How many chapters you have already done?
Ma'am, we just finished the first chapter.
Okay, and what about you, Shri Harsha?
Ma'am, we finished the second chapter.
Okay, fine. All right, so question number 6. So it is saying that explain why these numbers, they are composite numbers, right? So it's very simple. Like look at the first one. So 7 into 11 into 13 plus 13, right? So there is multiplication and addition. Now what will you do first? So you are going to use the BOD-MAS formula, which you already know BOD-MAS rule. So first you will do the multiplication and then you will do the addition, so that you will multiply first and then you will add into 13. So just multiply 7 into 11 into 13. What will you get? So it's going to be 77 into 13 plus 13. And how much is 77 into 13? Let me just check it quickly. Yeah, so it's going to come 1001, right? Plus 13. Okay, now just add it. So it's 4101, right? Now you can directly tell from here also what a composite number. First of all, they have 3 factors, right?
Yes, ma'am.
One factor is 1, the other factor is the number itself, and the third factor is some other number, right, Hamna? So here obviously this number is going to be it's going to have a factor 1, then the next factor is the number itself, but you can clearly see it is an even number, so it's a multiple of 2, right? So 2 is one of the factor of this number, so obviously it's a composite number. I mean, you can write, since it is an even number. So like the factors are or since it's an even number, so 2 is one of the factor. So it's a composite number. I mean, there is a factor which is apart from the number itself. Or there is another way of doing it. You can do the prime factorization of 1014. And what will you get? So 2 into 5, 0, 7, and then 3 into 1. Then you will get 20, 3 into 6, 18, and 27, 9. Then it is 13 into 13. It's a perfect square of 13, 169. So here also you can see it has more than 2 factors, right? One factor is 2, another factor is 3, then another factor is 13, the factor is 13. So I think you can do the next one similarly, right?
Yes, ma'am.
Okay. Now come to the next question. So there's a circular path around a sports field. Fine. Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes. Okay, so there's a circular field, let's say, just to understand. And suppose they both start at the same point. Like this is the point they have started and go in the same direction. Okay, so both are going in the same direction. After how many minutes will they meet again at the starting point? Now, first of all, try to understand what exactly we have to do in this question. I mean, the solution is just 1 minute, 1 second solution, but you should understand what he is asking here. Okay, like write it properly. So time taken by Sonia. So Sonia is basically taking 18 minutes per round, right? And similarly, Ravi, he's taking 12 minutes per round. Fine. Now, because they have a different speed, who is moving faster here?
Ravi.
Ravi, obviously, he's taking 12 minutes. So they will make certain rounds, and it might happen that at a particular round, they might meet again at the same point. So let's say after X point round, they are meeting, right? Let Sonia meet Ravi after X rounds. So what will be the total time she has taken so far? Like 18 minutes for one round, and for X round, it will be
18x.
18 into X, right? And similarly, let Ravi meet Sonia after y rounds. Or okay. Now, so the time taken by Ravi will become 12y. Or time taken, it will be 12y. Fine. Now, since we are saying they are meeting at the same point, so I mean at particular instance, this time will be equal to this time. I mean that is why they are meeting, right? We are talking about that time at which they are meeting. So at that time, this time will become equal to this time. I mean this is the instant. So when they are meeting, like when they meet, so this 18x will be equal to 12y. Is this clear?
Yes.
Okay. Now, see, how to understand, make it clear. Now, x is a multiple of 18, right? And y is a multiple of 12. You can see from here, right? Like x is some multiple of 18. It might be 18 into 1. It might be 18 into 2. It might be 18 into 3, something like that. Fine.
Yes.
Similarly, y is a multiple of 12. But we have to find the minimum time at which they are meeting. I mean, the first time they are meeting. They might meet again after that also, right? In the second, at some other time. But we are calculating the minimum time they are meeting. So that is why we have to find the least common factor of 18 and 12. I mean, there should be the least number which, when multiplied with x and y, I mean, that will give you the minimum time at which the Sonia and Ravi meet. Fine. So since we are finding the minimum time, we have to find the least common factor. Least common factor of 18 and 12. So basically in this, sorry, 12, not 1, 1, 2, it's 12. So basically you were supposed to find the LCM in this question, but I mean, did all this to make you understand what exactly we are doing. So that is, or you can write that is LCM of 18 and 12, right? So this you can find, you know how to find the LCM. Tell me quickly, what is the LCM of 18 and 12? Yes, Hamna, Shri Harsha, do it.
Ma'am, 36.
36. Okay, so 36 is the answer. Yes, Shri Harsha, any confusion in this question?
No, ma'am.
Okay. See, we are finding the LCM, as I told you. 18 can be multiplied by 18 into 1, 18 into 2, 18 into 3, like that. Similarly, y can also have different values, 1, 2, 3, 4, 5, like that. So we have to find that minimum value at which they will become equal. So that like the LCM will give you that minimum, the least factor. Okay. Okay, now let's come to the next exercise. So this exercise is over. Okay, so now we will begin with a theorem. So I'll give you an introduction first of all, a little bit, and then we will proceed towards the exercise. Now there's a theorem which you have to remember. Let a is a positive integer. A, okay, is a positive integer. And p is a prime number. So if p divides a, sorry, if P divides A square, then P divides A. Yes, please note it down because we are going to use it in the next exercise. So this is nothing like A is a positive integer and P is a prime number. So take any positive integer. Let's say you have an integer 5, right? Your A is 5 and P is any prime number. No, it will not be. Like take it 6, okay? And P is any prime number which is 2. So if P is dividing A square, that means 36 divided by 2, right? So A is also divided by P. That means 36 under root of 36, 6, right? So 6 will also be divisible by 2. Is this clear?
Yes, ma'am.
Okay.
Yes.
Right. Okay, next theorem. So take it as a question or as a theorem because it can be asked in your exam. We have to show, not show, like root 2 is irrational. In your book, it is given as a theorem. Like you have to remember it. You can use this result in other questions. Root 2 is irrational. So we will prove it. So we will do the proof and we will show that root 2 is irrational. Is this clear? So consider it as a theorem. So here we are going to use a method of contradiction. So first of all, we are going to assume the opposite. We will assume that root 2 is rational and then we will prove that no, this assumption was wrong and it is irrational. This approach we are using. Fine. So let us assume that root 2 is rational. So we will start from here. Clear? Now you know any rational number is of the form P by Q, isn't it?
Yes, ma'am.
Okay. So root 2 is equal to P by Q, where P and Q are integers. This you all know. P and Q are integers and Q is not equal to 0. Right? Now, what we will do is, first of all, we will reduce it to the least form. It can be a number like this, P by Q. Yes, Hamna, are you there?
Yes, ma'am.
Okay, so P by Q can be like this, isn't it? It can be 14 by 6. It can be like this. So first of all, we will reduce it to the minimum value. We will make it 7 by 3, like that. Yes, sorry. Okay, so first of all, we will reduce it to the least value. So, we see this is a prime number. 7 is a prime number. You can see 7 is a prime number and 3 is also a prime number. So we are going to reduce it in terms of prime numbers. Okay.
Yes, ma'am.
Okay. So suppose P and Q have a common factor. Other than 1, obviously 1 is always there, but other than 1, they have a common factor because we don't know what is P and what is Q. So they might have a common factor. So let's say they have a common factor other than 1. So we divide by the common factor to get the simplest form. So in the first question, I'm writing everything, then later on you can just reduce it. So we divide by the common factor to get the simplest form. Right? So let's say I have divided and I have obtained some other numbers now. So now now my root 2 has become a upon b. So a upon b are the simplest form now, a upon b. So now where a and b are co-primes. What are co-primes?
They don't have any other factors, common factors other than 1.
Exactly. So a and b are co-primes. So this means we have reduced it to the simplest form. Obviously, they are integers, but they are co-primes also. I mean, they don't have any factor in between them. Okay. Now, so just cross multiply. So this root 2 into b is equal to a, and just squaring both sides. So root 2 into b whole square is equal to your a square, and you get 2b square is equal to a square. Clear? So now you can see that 2 divides a square, isn't it? I mean, this 2 will become go in the denominator and it will divide a square. So 2 is a factor of a square. Yes?
Yes, ma'am.
Okay. So this implies that 2 divides a square. Okay. So by theorem, 2 also divides a. The theorem we have studied just now. So 2 also divides a. Okay. So far. Now let us just name this equation your 1, I'm saying. Just mark it. And this result I'm marking with 2. Clear? Okay. So now since 2 divides a, so that means 2 into some other number will be equal to a. Clear? From this equation, you can see that 2 divides a, right? 2 into some other integer c will be equal to a. Isn't it, Hamna?
Yes, ma'am.
I mean, from here, I'm writing that 2c is equal to a, where c is any integer. C is some integer. Now just put this result in 1, substituting in 1. So this will give you 2b square is equal to, so in place of a, I'm writing 2c whole square. So 2b square is equal to your 4c square, and then b square is equal to 2c square. Clear? Okay. Now here you can say that 2 divides b square, isn't it? Because 2 can come here in the denominator. I mean, b square is equal to 2 into some integer. So that is why 2 is a factor of b square. That means 2 is going to divide b square. Clear, Shri Harsha?
Yes, ma'am.
Okay, so it is 2 into something. So obviously 2 is one of the factor. Okay. So I can write that, I mean, this implies that 2 divides b square. And by theorem, I can write, by theorem, 2 also divides b. Right? So I'm marking this result as 3. Okay. Now 2 is also dividing a and 2 is also dividing b. So 2 is a common factor of a and b. Yes?
Yes, ma'am.
Okay. So from second and third, I can say, from second and third, we can say we can see, or say like we can see that 2 is a common factor of A and B. Okay. Now, this has contradicted our assumption that A and B are co-primes. We have already reduced P by Q to the simplest form. See, we took root 2 as a rational number. That means root 2 is equal to P by Q. Then we have reduced this P by Q in its simplest form so that we can get it in terms of A upon B. That is what we are doing, right? So when it is in simplest form, that means A and B are co-primes. But our result is telling us that there is a common factor between them, like 2 is a common factor. So that means it has contradicted our assumption, isn't it? So we can just simply write it like this, but this, okay. But this contradicts our assumption. Or sorry, this contradicts the fact, not the assumption, contradicts the fact that A and B have no common factor. Other than 1. Now, this contradiction is arising because we have assumed the wrong thing in the starting. We have assumed that under root 2 was rational. That is why this contradiction is coming here, right? So we will write this contradiction is because of our wrong assumption. Is because of our wrong assumption that root 2 is rational. So therefore we conclude, or so we conclude, that root 2 is irrational. Yeah. Is this clear to both of you? Any confusion?
No, ma'am.
No, ma'am.
Okay, so this is the way you're supposed to write it. So take it as a theorem. You can directly use the result always that root 2 is irrational. So you can use this result to prove other results sometimes. This is a theorem. Okay, next. Have you noted?
Yes, ma'am.
So let's do the examples also, because in this exercise, examples are important. They might be asked in your examination. So this is your example third. Prove that root 3 is irrational. Should I do it, or can you do it like similarly? Can you do it? Okay, let's do it.
Ma'am, we can do it.
Yes, Hamna, should I repeat it?
No, ma'am.
Okay, exactly the same way. The same things you have to write. In place of 3, you will get 2. That's it. So there you will get 3 as a common factor. And in the case of root 2, you were getting 2 as a common factor. Clearly? Okay, so I'm just proceeding towards the next question. Okay, I'm leaving this for you. Now next, now remember some results. You have already studied rational and irrational numbers, the operations of rational and irrational numbers. So when we add a rational number plus an irrational number, what we get?
Ma'am, can you repeat?
Yes, if I add a rational number and an irrational number, what kind of number I'm going to get?
Irrational.
Irrational. You can just convert it into numbers. Let's say you have 5 and plus root 3, something like that. So obviously it will remain 5 plus root 3. You cannot add 5 into root 3, right? So it's an irrational number. So it will give you an irrational number. Similarly, subtraction also, it is r minus I or I minus r. You are subtracting irrational from rational or rational from irrational. So this will also give you an irrational number. Clear? Okay. So we will do one question based on this and we will show that this operation gives you an irrational number. And similarly, there is another operation, like if you multiply a rational number with an irrational number, what kind of number will you get?
Irrational.
Irrational, obviously. See, you have 4 and you multiply with a irrational number root 2. So it will remain 4 root 2, right? You cannot do anything here. Yes. So it will remain an irrational number. So this will also give you an irrational number. And also if you divide, like you are dividing rational by irrational or irrational by rational, this will also give you an irrational number. Clear?
Yes, ma'am.
Okay. So based upon these operations, you have your next example. So let us quickly do that example. Now in this example, you have to show that 5 minus root 3 is irrational. Okay, let's do it. Okay, solution, no proof, whatever. Same method we are going to use. We will use the method of contradiction. So assume that 5 minus root 3 is rational, right? Okay. So if it is rational, then obviously it is of the form of p by q. So 5 minus root 3 is equal to p by q, where you know p and q are integers. And q is not equal to 0. Fine. Okay. Now again, we will do the same thing. We will reduce it into the simplest form. So suppose p and q have a common factor. Other than 1. So we divide by the common factor to get the simplest form.
Ma'am, can we directly write that P and Q are co-prime?
Exactly. Yes, we can directly do it also. This is just one step addition. I'm just writing to make, I'm just doing it stepwise. In the next question, I'm just going to skip this step. You can directly write it also. That's fine.
Okay, ma'am.
So, just to make things clear to you, that's it. Obviously you have studied the form of p by q so far for rational numbers. So that is why I'm just adding one step extra. So we divide by the common factor. I'll tell you both ways of writing to get the simplest form. Okay, so now I have divided and I'll get it now in the form of a by b. So 5 minus root 3 will now become a upon b, right? Now a and b are co-primes. Yes, is this clear, Hamna? And obviously b is not equal to 0. Yes, Hamna, clear? Okay, so
Okay.
just rearrange it. 5 minus is equal to root 3. Okay. Now look at the left hand side. can I just write it like this? 5b minus a upon a. I mean, I have taken the LCM is equal to root 3, right? So if you look at the LHS, like the left hand side, so you can see 5, since a and b are co-primes, right? They are integers, obviously. So 5 into an integer is also an integer, isn't it? Like 5 multiplied with some integer is also an integer.
Yes, ma'am.
And then minus, you have another integer. And then divided by, you have an integer. So integer minus integer will also give you an integer, isn't it?
Yes, ma'am.
I mean, take an integer, whatever, 2 minus 3, it will give you minus 1, which is an integer, or 6 minus 4 will give you an integer. So integer upon integer you are getting. An integer upon integer is also an integer, right? So on the left hand side, you are getting an integer, which is a rational number, isn't it? I mean, as I told you, the rational number includes everything. Rational number includes integers, it includes whole numbers, it includes natural numbers, the diagram which I told you in the previous class. So since your LHS or left hand side is rational,
Ma'am, is it 5b minus a by a or b?
I'm sorry, yes, it's B, you're right, my mistake. Okay, since LHS is rational, so root 3 is rational. When LHS is equal to RHS, that means if you have a rational quantity on the left hand side, obviously you have a rational quantity on the right hand side. That is why you have an equal to sign. Yes. So, I mean, this equation is telling me that my left hand side is rational. So obviously root 3 is rational. But this contradicts the fact that root 3 is irrational because we have already proved it. Yes, in the previous example, we have already proved that root 3 is irrational. So this contradicts the fact that root 3 is irrational. So this contradiction is because of our wrong assumption.
Ma'am, so when we're doing such questions, we should already prove before only that root 3 is irrational, or can we just start by this?
Yes, you can start from here only. Like if this type of question is given, so you can directly use the result that root 3 is irrational.
Okay, ma'am.
Wrong assumption. Sometimes it can also be asked like that in the exam, or that uh, if root 3 is irrational, then prove 5 minus root 3 is also irrational. Like that it can be asked. So, I mean, it is given that root 3 is irrational, right?
Yes.
This contradiction is because of our wrong assumption that 5 minus root 3 is rational. So we conclude that 5 minus root 3 is irrational. Okay, Shri Harsha, so what did your teacher said? Like, are you supposed to prove root 3 is rational first of all or not?
Yes, ma'am. My teacher told to prove that also.
Okay. All right. Like if she's saying you can prove it first of all, and then you can directly use the result here.
Okay, ma'am.
I mean, that depends upon the question. As I'm saying, if the question is asked like that if root 3 is irrational, then prove 5 minus root 3 is irrational. So in that case, that means it is already given it is irrational. So then you don't have to do it. And I think if it's not given, so then you will first show it as irrational and then you will use it here, right?
Okay, ma'am.
Okay. Yes, next example. Yes, have you written Hamna? Anyway, this was example of the book. So in the next question, you have to show that 3 root 2 is irrational. So this is based upon the multiplication operation. That rational number multiplied by irrational number will give you an irrational number. So that you have to prove. Okay, let's do the proof here or solution. Same, assume that 3 root 2 is rational. Okay, so Shri Harsha, now in this question, I'm directly writing. So I'm skipping the step. So I think now you understand what I am writing, right? So that is why I was writing that step in the previous questions.
Okay, ma'am.
Okay, so we can find coprimes. A and B such that my 3 root 2 is of the form A by B. So I've directly written coprime. So I'm not using the term like obviously A and B are integers, but I've also included another term which is coprime. So that means it is already in its simplest form, right, Hamna? So my one step is already reduced here. So just A and B are integers. And obviously B is not equal to 0. Okay. So just root 2 is equal to A upon 3B. I can write it. Okay. Now look at the right hand side. RHS. Look here. So in the RHS, you have an integer in the numerator and then 3 multiplied by an integer, right? So 3 into integer is also another integer. So now you have an integer divided by integer. So it will give you an integer only, isn't? Or you can say a rational number which is of the form of P by Q. Clear?
Yes, ma'am.
Yes. So that means your right hand side is a rational number. Since A and B are integers, so RHS is rational. So root 2 is rational. But this contradicts the fact so this contradicts the fact that root 2 is irrational. Right? So the same line you have to write again that this contradiction is arising because of our wrong assumption, and therefore root 2 is, A upon, what was the question? Sorry.
3 root.
2, yeah, 3 root 2 is irrational. But this contradiction is because of our wrong assumption. Okay, you can write the line. I'm just skipping it. So we conclude that 3 root 2 is irrational. Yes, Hamna, clear?
Yes, ma'am.
Okay. Okay, then let's move quickly to the exercise. So I think we are going to complete the chapter today because the next exercise is not in your syllabus anymore. So if you want to do, I can do. And if you want to skip, I can also skip that. What you want. So we will do one thing. Exercise 1.4. We will. Should I skip, Shri Harsha, or you want to do that?
Ma'am, you can decide.
Okay, we can skip for the time being, and later on we can see that, right? Because it's not going to ask in your exam.
Okay, ma'am.
So whenever we will get some time, then we will do it.
Ma'am, so for this lesson, only 2 exercises are coming.
Yes, only 1.2 and 1.3.
Okay, ma'am.
Yeah, the first chapter is first exercise is also not coming, and the fourth one is also not coming. So have you seen the revised syllabus, both of you? Even in this chapter 2 exercise are not coming, 2.3 and 2.4. Okay, I can provide you the revised syllabus if you wish. Just like send me your name on WhatsApp and I'll just forward you the file. I already have it if you want.
Okay.
Yes. Now prove that root 5 is irrational. Should I do this question? Yes, Hamna, should I do it?
No, ma'am. I'm good.
This is exactly same as root 3 and root 2. That kind of question. Yes, Shri Harsha?
Yes, ma'am.
Okay. And the second question, I think the same question we have already done, isn't it?
Yes, ma'am. We can do it.
Okay. So I'm just 3 plus 2 root 5. So you will get it in the form of a by b. Clear? So you will just make it 3 minus a by b is equal to 2 root 5. Like that you can do. And then from here you will get 3b minus a divided by 2b. This is equal to root 5. Clear? So this is your LHS, this is your RHS. This you have already assumed to be rational, right? And your LHS, sorry, in the beginning you will assume it to be rational. Sorry, not this. I'm sorry. You will assume this to be rational, not this. This will be root 5. Okay, now if you look at your LHS, so this is integer minus integer divided by integer. So this is integer upon integer kind of thing you are getting. That means it is rational. So your left hand side is rational and right hand side, which is under root 5, which is irrational, you have already proved. So your contradiction has arisen and then you can conclude. Is this clear?
Yes, ma'am.
Okay, so I'm just skipping this. Third one, let us do the third one. Third question. Now prove 1 upon root 2 is irrational. Let's do this one first. So same thing, let us assume 1 upon root 2 is rational. Okay. Now I can write 1 upon root 2 in terms of a upon b, where a and b are, okay, just so we can find co-primes, write this line. So we can find co-primes A and B such that, clear? This is how we are writing, such that 1 upon root 2 is equal to A and B, A upon B. Obviously, A and B are integers, and A is not equal to 0. Okay. Now, just,
Ma'am, B is not equal to 0.
yeah, I was coming to it, but in the next step, I was coming to it. So just like make reciprocal. So root 2 is equal to B upon A. No, what I have done? Oh, sorry, B is not equal to 0. Yes, in the beginning, B is not equal to 0. But now here I'm getting root 2 is equal to B by A. So obviously A is also not equal to 0. I was coming to this. Yes.
Okay, ma'am.
So if I'm writing it like B upon A, so A should also not be equal to 0. Now look at the RHS here, my right hand side. So you have an integer divided by an integer. It is going to give you an integer. I mean, you don't have to write this. This is just I'm explaining. So this is integer upon integer. That means it's a rational number or an integer. I mean, integer is also rational, you know. So your right hand side is rational, but you already know that root 2 is irrational. So there's a contradiction here. So just simply write, since RHS is rational, this contradicts the fact that root 2 is irrational. So according to this question, your root 2 is coming out to be rational, but you already know it is irrational. So there's a contradiction. And so we conclude, I mean, this contradiction has arisen right the same line. So we conclude that 1 upon 2 is irrational. So you have to write the line here, right? This contradiction. So I'm just leaving that line for you. Clear? Yes, written.
Yes, ma'am.
Okay. Next is what? 7 root 5. Well, let us quickly see this. I'm not writing the whole thing. So you have 7 into root 5. So you have to show this is irrational. So same way, like assume 7 root 5 is rational. Okay. So we can find co-primes. We can find co-primes A and B such that we can find A co-primes A and B such that 7 root 5 is equal to A upon B. A and B are integers and B is not equal to 0. Right. So just root 5 is equal to A upon 7 into B. I mean, you have to leave the irrational number or the root number on one side and take the things on the other side, rest of the things. Now look at your RHS. So this is an integer and 7 multiplied by an integer is also an integer, isn't it? So you have integer upon integer, which is rational. So your RHS is rational. This contradicts the fact that root 5 is irrational. So your question is telling you that root 5 is rational because you have a rational quantity on the right hand side. But you already know that root 5 is irrational. So this contradiction is arising because of our wrong assumption. That 7 root 5 is rational. So we conclude that 7 root 5 is irrational. Clear?
Yes, ma'am.
Okay. Okay, I think I can leave the next one for you. What is the 6 plus root 2 that you can do, right?
Yes, ma'am.
Yes, ma'am.
6 plus root 2. All right, so according to me, this chapter is over. So I think we should start the next chapter from the next class.
Okay, ma'am.
So should I start chapter number 2 or some other chapter you want? Polynomials.
Chapter number 2.
Okay, chapter number 2 we will do. Fine then, let's meet in the next class on Tuesday. When do
Thank you.
we have Eid? Which day? Just let me check. Eid is on, you have Eid on Monday, right?
Yes,
And
ma'am.
we have Eid on Tuesday. So I think Tuesday we will not be having the class. So we will meet on next Thursday now. Yes?
Okay, ma'am.
No, but Saturday we have a class. Yes. Okay, we will meet on Saturday. All right. Okay, thank you.
Thank you, ma'am.
Okay, bye.
Thank you, ma'am.